Hi guys, welcome back. So question 4, there's the sponsors, give them a tick. We are on the 2016 paper, 2A, question 4A. Well, question 4. For a piece of coursework, Tom and Amy decided to investigate cars passing their school between 3 p.m. and 4 p.m. Describe the population in their investigation. So the population is the cars which pass the school between 3 and 4 p.m. Interesting coursework. Bit weird that, but fair play. Maybe they like cars. Okay, part B. Tom and Amy each used a speed gun to measure the speeds of a sample of cars. Using the information in the table, calculate to 1 decimal place the point estimate for the population mean. So that's going to mean find the mean of all these values. So our Tom values, 10 times by 24.1 is going to give us 241. And then 20 times by 23.1 is going to give us 462. And if we add those together, that gives us 730. And then we divide by the 30 cars that we've got, which gives us 23.433. And it wants it to 1 decimal place, meaning that it's 23.4. Okay, that's part B done. Part C. Tom also recorded the make and model of each car in his sample. For each car, he found the figures for the fuel economy in miles per gallon, the CO2 emissions in grams per kilometre. He also plotted F against C on this scatter diagram. Calculate the equation of the regression line of F on C. Draw the regression line on the scatter diagram, and you may use the table below if you wish. So I'm going to just put these in. I should have probably done it off camera, but while I'm doing it, I can talk to you about this. So these values are what you'll be putting into your calculator in the table form. Oh, made a mistake. 107, I'm putting too many 107s. Start again. So these are what you should be putting in to your calculator, and you must put them in a table and they must match because they are coordinates. So if you put in different values, you're going to get a totally different regression line if you put them in a different order. 66, 63, 58, 54, 49, 47, 51. Okay, so now the way that you put these in, now this is for the CG50. You hit F2. I just want to make sure, yeah, you've got to be in stats mode. When you go to menu, it's bit 2. So menu and section 2. So you hit F2, which says calc. You do F3, which is your regression line. This is after you've put all of these into the tables and they've got to be in 2 columns. F1, which is X, and then F2, you're going to want that in A plus BX. Okay, once we've done all that, we get an equation which is F equals 114.7, take away 0.48 C. Now, when I've put this in to the graph, I've drawn the regression line. I've said, well, if C is 100 and if C is 120, what will F be? And that will give me 2 coordinates so I can draw my regression line. So the top one, 66.7, and the bottom one, 57.1. Going back up to here, 120 is at 57.1, which plots it there. 100 is at 66.7, so I'm just going to put it into there. And then it's a matter of drawing the ruler, getting it in between both lines. 26 degrees looks good. Okay, and then my regression line is drawn. So I'm happy with that. Okay, that's part C. I have to go through these with notes before I start working on them, otherwise I'll just get myself in a muddle. You have to pay a vehicle tax if you own a car. The vehicle tax you pay depends on the CO2 emissions of your car as shown in the table. You want to buy a car for which the vehicle tax is not more than £30 per year. So it has to be something within A, B, or C. Use the graph or the equation of the regression line on F, or of F on C, to estimate the minimum fuel economy for the car you might buy. So luckily earlier I used 120, and I didn't mean to, I just plucked it out of thin air. So 120, F equals 57.1 as stated earlier. Now, what you may want to do if you weren't as lucky as I was to come up to here, find out where 120 is, draw the line, go across, and then read that value, and that will give you your fuel emission. Right, that is it. That is question 4. How many marks was that? 3, 9, 9, 12, 14 marks. That is a big chunk of your grade. So make sure you know how to use your regression lines and you know how to plot them on a graph. Right, team, all done. I'll see you at the next question.